everyone. Today I'll be presenting a topic that plays a really powerful role in the way we interact with search engines, and that is nothing but query reformulation methods. Presented by Anchasati B26. Today's date is 11th March. So, getting to the part of introduction, let's start with basic, the definition. So, the query reformulation is a process of modifying a user's search query to simply get better results for the user itself. Then, why is it important? Because users often enter vague and ambiguous queries. For example, if someone just types Apple, then what do you mean? Either do you mean fruit or company or anything else? So, search engine will like Google, Microsoft Bing, etc. Don't just take that query as it is. They silently reformulate it behind the scenes, maybe adding terms like Apple INC for incorporation, or checking what similar users mean. So that's query reformulation in actual practical life. So after that, there might be some spelling errors. So misspells like typing restaurant RESTUARANT instead of RESTAURANT. So that will be a problem. Then entering short queries like just writing a climate. So, by writing a climate, what do you mean actually? Either you want the today's climate or sorry, today's weather or something else. That's not clear. Or sometimes it gets expanded also to get the meaningful results. Then yeah, types of query reformulation. Very first is a query expansion. This is when we add related or the synonymous terms to the query. Let's say, for example, car can also be more relevantly fetched in documents, like expanding the car to car, comma, automobile, comma, vehicle, etc., like that. So it brings to more relevant documents, especially if those other terms appear in high quality resources. So that is really useful. Then second one is query reduction. So it removes relevant, less relevant, or the noisy terms. For example, if we take buying cheap, reliable laptop 2025, let's say this is a query that is entered by user. So in that case, what will happen is simply the buy and 2025, these options will get eliminated. The remaining query will be cheap, reliable laptop. That's how it would be looking like. So in that way, query reduction is being performed. Then there is a query substitution, replacing original terms with better synonyms. So for example, if we take someone queried heart attack cure, if someone queried heart attack cure, so the search engine will simply modify the word cure and rewrite it treatment, which is a more technical medical term. Yeah. So in that way, then the relevance feedback based reformulation, quite important one, in which this is a dynamic approach to reformulate the query. So because based on how users interact with the results, the system reformulates the query. So if a user keeps clicking results related to used cars after searching only a word cars, then the system might prioritize that in future reformulations. In that way, this relevance feedback based reformulation works. Next one, techniques used. There are two types of techniques. First is the manual approaches, then the automatic approaches. In case of manual approaches, when the system gives a suggestion and the user tweaks their own query, it means they choose their own query. You have probably seen this in autocomplete mechanism. Whenever we write something in Google search engine, it automatically suggests us, like if we write or take an example of Apple again, so it may suggest us Apple company or Apple as a fruit, like that. There will be multiple suggestions by our search engine. So that will be how it would work, manual approach. Or it could also be did you mean prompts, like Earlier we used to generally see in Google search engine that whatever we type, if it feels that it is a wrong prompt, then it will simply ask us, did you mean this instead of this, like that. Then automatic approaches, much powerful ones. So they include thesaurus based expansion, like the example, uh, using wordnet to add the synonyms. Then the pseudo relevance feedback, which is actually the assuming the top results and expanding the query based on them. Yeah. And the third point is machine learning based reformulation. So of course the modern systems like Google search, and there is also one more famous search engine, u.com, which uses the models like BERT, BERT. I didn't remember its full form, but it is a deep learning model which is developed by Google in 2018, if I'm not wrong. So to understand the context behind the query and adjust it accordingly. So what it does is it does not only uh, see the word, the individual word itself, rather than it will map that word with a word behind that and a word after that in that complete sentence to fetch the actual context of the sentence. That's how it works. Sorry. Yeah. Then the third is the most important one, I think so. That is data, data sources, because all of these things relies on data. So data sources are most important. So query logs. In query logs, the query logs show what users have actually searched in the past. Yeah, as the name suggests itself. The name suggests itself. Then second is click through data, like helps track the results users actually clicked on after they search something. So that is the second one. The third is the knowledge bases, example Wikipedia or Google Scholars, all those. Yeah. So here comes the last PPT, applications and challenges. So in if we think of where is all of these things going to be used, so it's pretty clear that the the very first things where it is going to be used is web search engines like Google, Microsoft Bing. Nowadays we have a Brave search engine which is quite popular among youngsters. Then e-commerce platforms like Amazon, where the search reformulation actually can directly affect the sales of the company, so it is quite important over there. Then digital libraries. Yeah. So in this, the academic terms need precise interpretation. So the perfect example for this one is Google Scholars or IEEE databases, etc. Then the challenges. Here comes the great, interesting part. So over expansion, it can introduce noise if we, let's say, expand anything. If we say write Java and we try to include something else, anything, it could be like Java can be involved with coffee, tea, whatever you can say. So this will not work on the case. So ambiguity in user intent. So the words sometimes have multiple meanings depending on the context of a sentence. So that is going to be a real challenge. Then the real-time performance constraints. In the case, I would say systems need to reformulate queries and fetch results in milliseconds. So it is the, I think, the most important one, as I already um, mentioned, the e-commerce search, where the things are very critical in terms of suggesting the right products or on a right time. So this point plays a really critical role. Yeah. So yeah, that's it. Then the future directions, I think this point is already been majorly solved with the BERT algorithm, BERT algorithm developed by Google. But still, yeah, the system considers the recent searches, preferences, and even location of a person. Where also moving towards personalized reformulation, deeper neural IR models that understand the user just like a conversation partner itself. So it's something like that. Yeah. So that's it. uh, to wrap up, query reformulation is, we can say in a simpler word, it's a actual brain behind every search engine, because it fine tunes what we say into what we actually mean, and that helps us get better results faster. So thank you so much.